What if I told you that by simply observing the world around you, you're not just witnessing reality, but actively creating it? It might sound like science fiction, but what we've learned from quantum physics suggests something far stranger. The universe behaves differently depending on whether or not it's being observed. Stay tuned as we explore how consciousness and observation shape the very fabric of reality. Welcome back to the channel. Today we're diving into the idea in modern science, how the very act of observation shapes the universe. This isn't some abstract philosophical idea. It's grounded in the physics of atoms, particles, and quantum mechanics. Let's start with one of the most famous experiments that reveals just how bizarre reality can be: the double-slit experiment. Back in the 1800s, scientists believed that light was either a particle or a wave. But in the 1920s, a groundbreaking experiment by Thomas Young, and later refined by quantum physicists, showed something much stranger. The double-slit experiment showed that when light or particles, like electrons, are observed passing through two slits, they behave like particles, acting as solid entities. But when they aren't observed, they behave like waves, creating an interference pattern that suggests they're in multiple states at once. Here's the key part. When the particles weren't observed, they existed as waves of possibility. But once observed, they collapsed into a single particle, choosing a definite path. This is known as the observer effect, and it's one of the most famous mysteries in quantum physics. The very act of observation changed the outcome of the experiment. And this brings us to a shocking implication. The universe, at a quantum level, behaves differently when we're paying attention to it. You're not just a passive observer. You're actively influencing the reality around you. In the quantum world, things don't have fixed properties until they're measured. Until you observe them, they're not even decided. It's like the universe is waiting for you to take notice, and in doing so, you create its reality. This is where physics and consciousness collide. Building on the insights from the double-slit experiment, the concept of wave-particle duality is another fundamental anomaly in physics. Light, traditionally thought to behave as a wave, also exhibits characteristics of particles, photons, under certain conditions. In experiments like the photoelectric effect, light behaves as discrete packets of energy, or particles, rather than a continuous wave. But in other circumstances, like in the double-slit experiment, light acts as a wave, spreading out and creating interference patterns. This wave-particle duality suggests that the very nature of light, and possibly all matter, is not fixed, but changes based on how it's observed or measured. It challenges our classical understanding of particles and waves, implying that reality is not a set, stable thing, but is dependent on the observer's interaction with it. Schrödinger's cat experiment. Erwin Schrödinger's famous thought experiment presents a paradox that highlights the strange nature of quantum mechanics. In this experiment, a cat is placed inside a sealed box with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, it triggers the poison and kills the cat. If the atom doesn't decay, the cat remains alive. Quantum mechanics tells us that until we open the box and observe the cat, it exists in a superposition state, both alive and dead at the same time. It's only upon observation that the superposition collapses into one of the two possible outcomes. This thought experiment demonstrates the counterintuitive nature of quantum mechanics. Particles, or in this case, even a macroscopic object like a cat, can exist in multiple states until they are measured, similar to the behavior of particles in the double-slit experiment. While the double-slit experiment is the most famous illustration of the observer effect, it's not the only instance where observation impacts reality. For instance, in quantum optics, experiments with photons have shown that the behavior of light can change depending on whether or not it is being observed. When light passes through a series of slits, it can create interference patterns, acting like a wave. However, when detectors are placed to observe the path of the photons, they behave like particles, and the interference pattern disappears. This is similar to the double-slit experiment, but it also occurs in other quantum systems, including atoms and electrons. The observer effect suggests that the very presence of an observer, or even the potential for observation, can influence the state of a quantum system. This phenomenon raises fascinating questions about the role of consciousness or measurement in shaping the fabric of reality itself. These anomalies collectively show how our classical understanding of reality, where things are either in one state or another, breaks down at the quantum level. In the quantum world, particles and waves, potentialities and realities, are not distinct, but are part of a continuous dance between observation and existence. Each of these experiments challenges our intuitive sense of a fixed, stable universe and suggests that the very act of observing reality may be the key to creating it. Does it mean that our consciousness is somehow controlling the universe? Well, not exactly in the way you might think. It's not as if your thoughts alone can change the position of atoms or create material objects out of thin air. But the observation of particles and how those particles behave in response to our attention does suggest that consciousness plays a role in shaping the reality we experience. This implies that consciousness isn't just an emergent property of the brain, but could be interacting with the quantum field in ways we don't fully understand yet. Are we somehow shaping reality by simply observing it? Scientists don't have all the answers, but the idea that the observer is involved in shaping reality is one of the most profound implications of quantum physics. Our attention, our consciousness, might not just passively witness the universe, but help shape it at a fundamental level. The act of observation, at the quantum scale, could be the key that unlocks the universe's behavior. If this concept blows your mind like it did mine, don't forget to hit that like button, subscribe, and share your thoughts in the comments below. Do you think consciousness is tied to the universe in a deeper way than we realize? Or is this just a mind-bending paradox that still needs answers? Until next time, remember, you're not just observing the universe. You might be helping to create it. See you in the next video.